The Southern Ocean is another major dilemma for plate tectonists. In the Southern Ocean, all of the oceans and continents are actively spreading away from Antarctica, away and supposedly moving north into the northern hemisphere. And the spreading rate between Antarctica and Australia is around 65 millimetres per year, 6.5 centimetres per year. And as you saw in the previous animations, the cross-from ocean is essentially east-west, opening up the Atlantic and Indian Oceans, essentially east-west, and there's no net northern migration of these continents or oceans seen in these animations. There's also there is no physical evidence for active collision in the Arctic Ocean region with this huge amount of opening of the Southern Ocean. It's got to go somewhere. And as well as converging on the Pacific Ocean for the Atlantic and Indian, it's supposedly converging on the Arctic Ocean as well. And there's just absolutely no record in this region of convergence. Now I've got another animation which may not work. No. And this is a very important one. What I'm trying to show is each of the globes that I constructed revolving once and then pop down to the next globe. So what I'm simply doing is removing each coloured stripe in turn, popping them down into the next globe and then continuing right through the sequence, and this is going to be a disaster. Similar to the sequencing slides before, where they just pop through back in time and then come forward again. You do that. Yeah. So what I've done here is simply rotated each globe and then popped down to the next one so you can actually see the transformation back in time and then moving forwards in time. This interval time, the time covered by this animation is about 200 million years. And this represents closing off of the oceans, remembering right from the start, this Otto Hilgenberg did this visually. We now have this oceanic mapping to physically quantify this closing off process back in time. It represents 4% of Earth history. Our total Earth geological time is about 4,600 million years, for those who don't know. And this 4% of Earth history represents about 70% of the expansion history, as I'll elaborate on shortly. And by using this mapping, I was able to show that each of these reconstructions are latitudinally and longitudinally constrained by the mapping. In other words, there is only one fit option. In plate tectonics, reconstructions are constrained by magnetic data, the location of the poles, the ancient poles. And if you know a little bit about that, their reconstructions are only constrained by latitude and they cannot constrain by longitude, so they have a multitude of fit options. So So any scientist can come in, make a reconstruction and say, yes, this is it, and it'll be completely different to another researcher. On an expanding Earth, we only have one fit option, and this is the key to this presentation, is that you only have one fit option. It is constrained latitudinally and longitudinally by both time and location.